Hi, I have a lesson on the Pythagorean Theorem and how we can use that to help us find missing sides in a right triangle. Before we go to actually using it, we have to figure out what is it. So what the Pythagorean Theorem tells us is, if a triangle is a right triangle, then we can use this little equation. A squared plus b squared equals to c squared. Now, what does that little equation mean, or where does it come from? Well, it comes from a right triangle. As you can see in my picture here, I have a right triangle because it has the little right angle symbol down here. Now, the A and the B deal with the legs of our right triangle. A is one leg, B is the other leg. Now, you can switch these around. So if you wanted this one to be the A and this one to be the B, you could definitely do that. It doesn't matter. The legs can be interchanged in the little equation A squared plus B squared equals C squared. However, C is the hypotenuse of your right triangle, the longest side of the right triangle, the side that is opposite the right angle. Many, many different ways to describe it. But that hypotenuse, we always use C. And notice in the equation, A squared plus B squared equals to C squared, C is the one thing all by itself. The A and the B, they're on one side, and the C is on the other side. So plug that little formula into your head, and it will be very useful as we look to find missing sides in our right triangles. So my first example here is, I have this right triangle, and I want to find the length of that missing side. So I'm going to use the Pythagorean Theorem. My a squared plus b squared equals to c squared. So I have a squared plus b squared equal to c squared. And we just have to figure out which one's A, which one's B, and which one's C. Remember, A and B have to be the legs. Now, I usually like to have A be the short leg and B be the long leg if I can tell the difference, and then C is the hypotenuse. So when I look at this, it appears that M is the short side. It doesn't have to be. So that's going to be like my A. The 16 is the other leg. That's going to be like my B. And then the 20, the hypotenuse, is my C. So now I just plug these numbers into this equation, and I look to solve it. So for A, I'm going to put in M. So I have M squared, and then plus B. B is the 16. So I have B squared equal to, and the hypotenuse is 20, so I take 20 and squared. Now, I look to solve this equation. Well, I want to get rid of those squares first. In other words, I have to square those two numbers, the 16. And if we square 16, we get 256. Square 20, we get 400. And now we have m squared plus 256 equal to 400. Next thing I would do is I would subtract the 256 to get the m squared all by itself. And now we have m squared equal to 144. And now this goes back to solving our little equations with squares in them. So to do that, I would take the square root of both sides, and I'd end up with m equal to, now remember in the equation, we have to look at both the positive and negative solutions when we take the square root, and the square root of 144 is 12. Now, I want you to think about that. We just figured out what a is, or the a side, which is our variable m in this case, but we got it to be positive 12 or negative 12. Do they both make sense? I hope you said no. It doesn't make sense for the side of a triangle to be a negative length. Therefore, when we're all done, we will answer this question and say that m, for our problem, will equal 12, and then we want to put our label on it, feet. So there's our final answer. I know the equation said that there were two solutions, but because we're dealing with the triangle and side lengths, there's only one solution to this one. Now my next one, I want to find the hypotenuse in this case, and we have to calculate its length. So again, I'm going to just go back here and I'm going to steal this little equation here because we're going to use the Pythagorean Theorem again. I'm going to copy that and come back over here, and we're going to paste it right here. We just have to figure out what's A, what's B, and what's C. Now this triangle is orientated a little bit different, so don't let that throw you. Sometimes it's easiest to find the hypotenuse, the side that's the biggest one or opposite the right angle, well, that's right here. There's our c. So that's the variable in this case. I'll put my x in there, and that's going to be squared, equal to, now I just define a and b. Now remember, a and b really don't matter which one's which. I like to, like I said, short side be a and long side be b, but it doesn't matter. And if I really look at this, I didn't draw this one to scale because this one looks like the long side, but it's 15 meters, which is definitely shorter than 36. So it's not drawn to scale, but that's okay. It doesn't have to be. And now I just plug in my numbers. So I'm going to put 15 in for A. I'm going to put 36 in for B. And now we're going to go through and we're going to solve this equation. Now I have to square them. 15 squared, that's one that I know off the top of my head. That's 225 plus 36 squared. I don't know that one, and it's going to equal x squared. So I'm going to grab my calculator to help me out. So 36 squared comes out to be 1,296. 1,296. I have to add those two numbers together. Add these two together. Go back to our calculator. Add on the 225, maybe, plus, oh, now I got that. Okay, there we go, plus 225 we're at 1,521. 1,521 equals x squared. Now, to solve that, remember, we have to now take the square root of both sides. If I take the square root of the left and square root of the right, right side's going to equal x. This side, we're going to have a plus or minus. I don't know the square root of 1,521 off the top of my head, so I go back to my calculator. To do that, I'm going to have to push second, and then I have the squared button as the square root as the second part of it. So second and then x squared, which gets me the square root like you see up there. And now I type in my 1,521 and I push enter and find out that it's 39. 1,521 is a perfect square. So this equals 39. Now again, like before, the negative's not going to make sense in this problem because we're dealing with the length of the hypotenuse. So when it's all said and done, x is going to equal 39 meters for the length of that hypotenuse. And now I have one more here. This one, no picture. So what I like to do is I like to draw the picture since it says the length of one leg in a right triangle. I have a right triangle. I just draw it like so. It says the length of one leg is 3 centimeters. So one of them's 3 centimeters. I'm going to put that here. It tells us the hypotenuse is 8 centimeters long. That would be right here in mine. How long is the other leg? I don't know that. Well, I look at the 3 being my A. I'll let this other side be B, and the 8 is the C. So here's my A, here's my C, and then B I already have. And then I'll use my equation that I had from before. A squared plus B squared equals C squared. We have a right triangle. And I just plug my numbers in. I'm going to put 3 in for A. I'm going to put 8 in for C. And I still don't know what B is. And then all the rest of this, I still have to square the A, add on the B squared, and it's going to equal to C squared. Well, let's solve. 3 squared is 9. 8 squared is 64. Plus our B squared. Now I'm going to subtract the 9 from both sides to get the B squared all by itself. And that's going to put us at 55. And now I have to take the square root of both sides. And the square root of 55 does not come out to be an integer value. So in this case, I'm gonna use my calculator to round that to the nearest tenth. So just like before, come back here. When I took the square root of 1,521, we'll do the same thing. I'm going to push second and then the squared button to get the square root part out. And now the square root of 55, my calculator will round that, and it's going to round it out a long ways. I'm just going to go to the nearest tenth So 7.4, I got to look at the 1. 1 tells me to leave the 4 as is. So my answer to this, or my approximate answer, is going to be B equals 7.4. We should have the plus or minus in that equation. But then I go back and say, well, we're trying to find the length of a side. So in the end, my other leg is going to be 7.4 centimeters long. And that's going to conclude my lesson on the Pythagorean theorem. So remember, if you have a right triangle, you can use a squared plus b squared equal to c squared to help you find those missing side lengths.